So we've established why someone might want to become a neurosurgeon, but why on earth would you want that for your child? Seriously, I mean, who on earth would think I want my child to grow up in a high intensity environment? I want them to be working tirelessly, and I want them to be constantly stressed, all for the same annual salary that Phil Fodden earns in 3 days. And the answer to that is pretty simple. It's the same person that has watched this far into the video. And to be honest, I'm not here to judge. We're so desperately in need of subscribers. You've come for an answer, and an answer you will get. So to answer this question, how do I turn my child into a brain surgeon, we really just need to strip everything back, and it really comes down to two key parts. It's all really down to kind of genetic factors and environmental factors. So what do we actually mean by genetic factors? Well, it really all comes down to the essential genetic material that's kept within your reproductive cells. So for the male, that's the spermatocyte, which is more commonly known as the sperm, and in the female, that is the oocyte, which is more commonly referred to as the egg. They come together during fertilization to form something called the zygote. That is when you have an exchange of DNA or genetic material from the male into the female. Over the next kind of hours to days, you get this kind of rapid progression of or expansion of cell numbers of the zygote, which originally divides into 2, subsequently 4, and then essentially 8, and then 16. This forms something called the morula, and these cell components build up and build up to they start to kind of form an organize, or they have enough capacity to form an organized structure called the blastocyst. And that's quite important because you see it has this kind of circular structure with this kind of clump of cells in the middle. And the reason that's so important is because this is essentially the prerequisite of forming the 3 layers, or the 3 kind of germ layers of an embryo. In this diagram here, you can see that the green color here is essentially something called the ectoderm. Ectoderm contributes to both the brain and the skin, which has always been thought to be incredibly cool. The purple part is the endoderm, which essentially contributes to your heart and blood vessels and so on. And this orange part is your mesoderm, which essentially kind of forms things like your muscles. You can see here from day 8, it's relatively simplistic structure, but then starts to become more and more complex through day 9 here. And this is an example of day 12. And what's really interesting about this is you can see these 3 different layers. So the mesoderm here, the endoderm in purple, and the ectoderm in green have started to form pretty much independent structures. And why is that relevant, or what's of interest with the kind of development of the brain? Well, obviously the topic of this talk really is how to turn your child into a brain surgeon. So for the purposes of this, we are really focused and interest on the brain. And like I said to you, the 3 components here are essentially the ectoderm, mesoderm, and endoderm. So if we exclude the endoderm in green, the mesoderm, and just focus on this ectoderm part here, which is of most interest to us, you can see the kind of dark blue part really is where the skin is essentially going to form, and the brain CNS, as it's called, central nervous system, which includes the brain and spinal cord, essentially will form out of this purple part with this kind of these pink edgings. So you can see really over a period of kind of 1 to 2 weeks, you can make this transition from this flat structure, which then starts to form something called the neural groove, which is this small groove here, starts to kind of form a deeper groove. And by around week 4 to 6 of embryological development, you then form something called the neural tube, which is the original kind of rudimentary part of your CNS, and the brain and spinal cord will essentially develop from this tubular structure. And the most important thing about the neural tube that you need to know is that is originally what this YouTube channel was going to be called, but we changed our mind at the last minute. And if you then kind of work your way how that is relevant to the actual embryo as it develops, you can see that this embryo here is essentially an example of a kind of 4-week-old embryo. And you can see how the kind of small structures are starting to form, this purple tube being relevant to the neural tube, and that's where its brain and spinal cord will form. By the time you get to kind of 10 weeks or so, it starts to kind of look a little bit more like a fetus, and then obviously by 24 weeks starts to look like a baby, and obviously, by 24 weeks it really just kind of strengthens and grows and gets ready for coming out into the world at that point, roughly between 37 to 40 weeks. And really you can see from essentially time point 0, from when the spermatocyte and the oocyte, or the sperm and the egg, come together to form this zygote, there's this rapid and continual progression of development of the cell structure, the cellular structures, and then into the embryo and then the fetus, and continues from that point right through to when the child is born. So the kind of moral of the story is that once that DNA essentially is locked in at the beginning, that issue's set for life. So the bottom line is, to make a high quality product, you have to have high quality ingredients. And for an example, say that ingredient is water. There is no way you can take the finest, purest water from an Icelandic spring and compare that to the pond water from your back garden. It just doesn't work. It's not the same ingredient. And the bottom line is if you do not get the analogy I'm creating right now, you've probably have nothing to worry about. So just, you've watched enough of this video for it to count as a view. Log off, join us for the next video, and thanks very much for your time. So you got the ingredients right. So now what next? Well, to be honest, now's the hard bit. It's the nurturing, or essentially the environment in which that child is raised. So we've just explored kind of how the brain develops through the various stages of how an embryo forms. But please don't think it's all done here. So we've just explored how the brain and central nervous system and the spinal cord develops through the embryonic phases of development, from essentially conception right up to the point of birth. But the question remains is, how does that development continue after the child is born? And really, this is a very important question to ask, because the infant brain will actually increase in size by about a factor of up to 5 times by the time it gets to adulthood, reaching a final size which essentially hosts around 86 billion neurons. And that is just such an incredible number. And there are 2 factors that really contribute to the main development of the brain through that time period. And the first one is what's called synapse formation between neurons. Now, just to make things quite simple, synapse formation of essentially neurons, this neuron here is this kind of purple neuron. Synapse formation is the communication between 2 different nerve cells, or 2 different brain cells. You can see essentially you got one brain cell here with its arm kind of hanging out in blue, and then the other brain cell here in kind of purple with its other arm. And essentially those 2 kind of coming together means that those 2 brain cells can actually communicate to each other. And how that actually happens is really essentially chemical release from inside the neurons. Every time a neuron kind of fires or transmits electricity down the length of itself, what it's doing, it's originally kind of packing in kind of vesicles or small kind of sacs filled with chemicals that it can then release onto another cell to kind of give it signals and instructions on how to act. And that's essentially what's called neurotransmission. The more synapses that you can make in a kind of positive direction during the kind of process of learning, the more that kind of learning will become easier and certain tasks will become easier. Now, the next important phase of development of a child's brain after birth is something called myelination, which is really a kind of fascinating feature. And quite simply, I'll explain it to you. So you've got this bare, naked purple neuron on the left, and essentially what is known as a myelinated nerve fibre in this centre part here. And essentially the myelination is these kind of lobules of yellow all the way down this axon, which is this long trajectory coming out of the neuron. Myelination of a neuron can quite simply be compared to the lagging of a pipe, or more accurately, the plastic insulation around an electric wire. And essentially what it does is it fulfills the same the same task, which is to provide insulation around the nerve fibre so that the electrical signals transfer from the neuronal head or body up here down to the end of the neuron more quickly and more efficiently than they would if there was no insulation around the nerve. And this is all done by this kind of fancy cell on the right hand side called an oligodendrocyte. Oligodendrocyte is one of the kind of more important cells in the brain, which has several functions, but in the context of myelination, what it does is it essentially puts every one of these different legs or feet onto a different neuron axon and provides this insulatory capacity to different nerves all at the same time. And when you have diseases that you may have heard of, such as multiple sclerosis, what that actually is a loss of these myelinating or protective sheaths round about the end of the neuron. When these protective insulating sheaths are removed because the oligodendrocyte dies, the conduction down the nerve fibre is lost, and that's why you get the neurological problems that you see in multiple sclerosis. So now we understand the two key principles that happen after birth and that it contribute to the development of the brain. But the question is how can I possibly improve synaptic formation and improve myelination so my child turns into a brain surgeon? Well, to be honest, it's pretty simple, and the answer is let them have fun. For years and years and years, there's a body of literature which is kind of built up and demonstrated that when children are happy and live in an enriched environment where they feel secure and loved, that they have continuous chemical spreading around the brain, which helps these synapses to develop and helps the maturity of the brain, which continually improves learning. And more importantly, every time they're having fun, they're exploring and they're learning new things, they feel this continual sense of achievement, which they do not feel if you're putting them in front of a book and forcing them to learn. Allowing them to have fun, allowing them to explore, and allowing them to experience their own learning environment and their own version of problem solving makes them appreciate essentially what achievement feels like. And on that day they finally get the hang of, say, reading a book or a maths problem or a science problem that they've been struggling with in the future. That sense of achievement which they've been allowed to have by playing and exploring at a young age allows them to kind of reinforce that behaviour when they become older. So the answer is pretty simple. How do I give my child the best chance of becoming a brain surgeon? Well, I mean, really it's just about finding a mate with a decent gene pool, procreating, and then letting your kids essentially explore in a positive, loving, enriched environment in a pressure-free way. Don't needlessly expose them to stress. Don't needlessly force them to do tasks that they don't feel comfortable with, and it'll all fall into place. And maybe at some point in the future, the skills and the experiences they had when they were young will direct them towards exploring a path which involves saving lives. Or maybe they might play for Man City. Who knows? Okay, until next time, thank you for subscribing. Please circulate the channel, keep subscribing, keep watching, and we'll see you with a new video very soon. Take care.